Today we're looking at lesson 2-1, starting activity 2, solving equations, with the theme of what's my number. We're going to try to use the algebraic method to solve an equation. We're also going to write and solve an equation to model real-world situations. Now, equations are mathematical statements that show two expressions are equal. Okay, so they basically need to have an equal sign to be an equation. If it's just an expression, which doesn't have an equal sign. The solution, whenever you see this word, just basically means what's the answer, okay, if you solved or if you were going to solve it. Number 1, make sense of problems, determine the number, and explain how you came up with the solution. If you multiply me by 3 and increase that number by 5, I am 20. What's my number? Now, one way we could do this is the old guess and check method. So I could just guess numbers until I happen to hit the right one. For example, I might guess 10. Multiply me by 3. 10 times 3 would be 30. Increase that by 5. Add 5. 35. That's not 20, so we know that 10 is not the number we're looking for. I could say 2. 2 times 3 is 6. Plus 5 is 11. That's not 20, so we know that 2 isn't the number. But we can say that, hey, that is between 2 and 10, between 11 and 35. So we know around where this number that we're looking for is going to be. And we could just keep trying numbers until we find out the right one. Let's say 5. 5 times 3 is 15. Increase that by 5, so 15 plus 5 is 20. That would be the number we're looking for. 5. Number 2 says you may have used an equation, although I didn't. We used the guess and check method to answer item 1. Write an equation that could be used to represent the problem in item 1. So let's look at the words they give us. You multiply me. Now we don't actually know what me is, so that's going to be our unknown. That's what we're going to write as our variable, x, or any letter that we pick. It could be A or C or Z, but we're just going to use x for this example. Multiply by 3, so x times 3, and increase that by 5 plus 5. If you remember your order of operations, you'll know you'll do this part first, multiplying and then adding. But if you want to make sure on certain parts that you're doing things in the order that you were told, you can add like parentheses, since you always do what's in parentheses first. X times 3 plus 5. And we know that it's going to give us 20 equals 20. That would be our equation. Let's go ahead to number 3. For each equation, tell whether the given value of x is a solution, whether it's an answer that actually works. And we'll have to explain. All right, so let's look at A. If I replace this x with what they tell me, x equals 6, what will I get? Well, we can rewrite the problem to show our work. It would be 6 minus 1 in parentheses. We want to see if this is equal to 22 to see if it's a solution. Parentheses first. 6 minus 1 is 5, so that would be 2 plus 4 times 5. 5 times 4 is 20, so 2 plus 20, because we do our multiplying next after we. And 2 plus 20 does equal 22, so this does check out. It is a solution. x equals 6 is a solution. Let's look at B. 12 minus x divided by 4 equals 8, and we're going to replace the x with 24 and work it out and see if it is a solution, if it's the right answer. So it would be 12 minus 24 divided by 4, and we're going to see if that equals 8. That's 12 minus 24 divided by 4 is 6. 12 minus 6 is 6, and 6, does that equal 8? No, it doesn't. So no, x equals 24 is not a solution. And usually when we have something that's not equal, we can strike it out with a little line through it like that. It looks over here, you can see it a little bit better. That way we can say 6 is not equal to 8. We just put a line crossing out the equal sign. 6 is not equal to 8. So no, it's not a solution. And the last one, it's got a little bit of decimal in it, but that shouldn't change what we need to do. We're going to replace the x with 0.9. So it'll be 3.8 plus 6 times 0.9. And we're going to see if that equals 8.6. Well, let's see. 3.8 plus, we're going to do our multiplying first. 6 times 0.9 is going to be 6 times 9 is 54, with one decimal place in it, 5.4. We'll see if that equals 8.6. 3.8 plus 5.4. Well, 4 and 8 is 12. You carry the 1. 4 and 5, that'll be 9. 9.2. Is that equal to 8.6? And so no, x equals 0.9 is not a solution. One way to solve an equation containing a variable is to use the algebraic method. This method is also called the symbolic method, or solving equation using symbols. Example A. Solve this equation, 3x plus 90 plus 2x equals 360, using the algebraic method, showing each step and listing a property or provide an explanation for each step. So our original equation we have here, they moved the 2x next to the 3x by using the commutative property of addition, if you'll remember from years ago, just says that you can add things in any order and still get the same answer. Combining the like terms, the things that are the same, 3x plus 2x, 3 plus 2 is 5. Remember our thing, you can add apples to apples, but just not apples and oranges. So I couldn't combine the 5x and the 90 because they're two different things. We're going to use the subtraction property of equality, which basically means if you subtract, or for that matter add or multiply or divide the same thing to both sides, you'll get a balanced formula. So it changes the numbers, but it doesn't really change the thing. It just changes the way they look. So 90 minus 90 is 0. 360 minus 90 is 270. So I have 5x plus equals 270. as I said, using the division property of equality, so just the division version of this, if we divide both sides by 5, because we want to get the x by itself, and 5 divided by 5 is 1, and 1x we just write as x, because it's just one of them. 270 divided by 5, so we have to do the same thing to the other side to keep it even and balanced. 270 divided by 5 is 54. Okay? Then they just showed us that if you can check this by substitution, by replacing the x with 54 in our original problem, it would be 3 times 54 plus 90 plus 2 times 54 equals 360. You can see that 162 plus 90 plus 108 equals 360. You add them all together, you do get 360 is equal to 360. So x equals 54 is a solution. It does work out. Just like in the earlier grades when you would have to check your answer, it just lets you know that you're doing it right. Because sometimes you would just keep going, and you don't want to do that if you did something in one of the earlier steps wrong, because it would throw off all of your work that you're going to do afterwards. So let's look at these down here. Try these. A. Solving the what's my number problem using the equation you wrote in item 2 and the algebraic method. So item 2, we said x times 3 plus 5 equals 20. Three x plus 5 equals 20. Make sure I wrote that correctly. Yes. This is the same thing as I wrote in number 2. It just looks a little bit better, more clean. Solve this using the algebraic method. We would first subtract 5 from both sides. So I'd say 3x plus 5 minus 5 equals 20 minus 5. That's the same properties they showed us up here. Subtraction property of equality. One that we should be used to since we're going to be solving a lot of equations throughout the year. 3x would be equal to 5 minus 5 is 0, so that would go away. We don't write plus 0 since we know it doesn't change anything. 20 minus 5 is 15. Okay, next we're going to use division again, so we're going to say 3x divided by 3 equals 15 divided by 3. And we want to divide by 3 because 3 divided by 3 is 1, and it'll just leave us with 1x. 15 divided by 3 is 5. So we used the algebraic method to solve for the what's my number problem, and we got 5, which is the same thing we got at the very beginning using the guess and check method. It just happened to take a lot longer when you guess and check, and the algebraic method was a shorter way, especially if it's a wider range of possibilities. Let's look at B through G. Solve each equation using the algebraic method, showing each step, list a property, or provide an explanation for each step. Remember to do the parts of the answer that they tell you. Try not to skip showing your work. Negative 5x minus 6 equals 1. All right, our first step, we want to move that minus 6 to the other side. So we'll do the opposite, and we'll add 6 to both sides. And that can be our addition of equality property. Trying to put it like they put it, addition property of equality. All right, so that'll leave us with negative 5x, and that will be equal to 1 plus 6, which is 7. Then we'll need to do the division property of equality to get rid of the negative 5. So we'll say negative 5x divided by negative 5 will equal to 7 divided by negative 5. Division property of equality. Negative 5x divided by negative 5x. A negative divided by a negative is a positive, so it's just x. A 7 divided by negative 5, that's an improper fraction. We can move the negative sign to the front and say negative 7 divided by 5. Or we could write it as an a mixed number, which is negative 1 2/5. Negative 7/5 or negative 1 2/5. We'll look at one more, C. 12d plus 2 minus 3d equals 5. Well, let's combine our like terms first. Or using the commutative property, we can move things around so it's easier to see what we're combining. 12d minus 3d plus 2 equals 5. That was the commutative property. 12d minus 3d, it's 9d, plus 2 equals 5. Combine like terms. We will subtract 2 from both sides to get the 9d by itself. Subtraction property of equality. So we'll have 9d equals 5. Sorry, 3. 5 minus 2 is 3. Gotta watch out for going too fast in your head and missing certain things. We'll divide both sides by 9 to get rid of this coefficient. Coefficient is the word for the numbers in front of a variable. So 9d divided by 9 will equal 3 divided by 9. Division equality property. 9 divided by 9 is 1d. 3 divided by 9 is, if you reduce, 1/3. If we wanted to check, we could multiply 12 times 1/3 and 3 times 1/3, add 2, and then subtract what answer it was. So let's see. 12 times 1/3 is 4. 3 times 1/3 is 1. So it's going to be 4 plus 2, which is 6, minus 1, which is 5. And that would be correct. That is our solution. Try D through 10 for now. Try through D here. still playing with this program. I don't know how to take that out. But do try D through 10 just for today. If you need more practice, you can continue on 11 through 17. But I think if you can get D through 10, you should have a fairly reasonable understanding of the process for today.